And next we have Coulomb's law. In the case of Coulomb's law, we need to take two charges such as Q1, Q2. There is a separation between them from center to center, and the distance of separation is r here. Then Coulomb says that there exists a force between the two charges. It may be attractive or it may be repulsive, depending on the type of charge. That force in magnitude is directly proportional to the product of the charges. So you have Q1, Q2 here. And in the second case, the same force between the charges, it varies inversely with the square of the distance between them. So if you combine the two equations, it becomes F is proportional to Q1, Q2 divided by R square. So this is what you get here. So if you look at the statement, it says that 2 point charges attract or repel each other with a force which is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. So now coming back to this equation, you should get a constant here. F is equal to a constant K, Q1, Q2 divided by R square. And this constant K is equivalent to 1 divided by 4 pi epsilon naught Q1, Q2 divided by R square. And this whole term, this is equivalent to the constant K here. And we are having a value here. This is epsilon naught. This is known as absolute permittivity of free space. And the value of absolute permittivity of free space is given as 8.854 times 10 negative 12 Coulomb square per Newton per meter square. And let us see how do you get this unit here. From the equation, F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. Now let us put the unit now. Force for Newton in SI is equal to 1 divided by 4 and apply. These both are constants without any unit. But you have epsilon naught here. So let us write down epsilon naught here. Q1, Q2. You have two charges, so Coulomb, it becomes Coulomb square divided by R for the distance, meter square. So from it, you get epsilon naught is equal to Coulomb square per Newton per meter square. This is the SI unit of absolute permittivity of free space. Now coming back to our equation, F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. This is the equation when the two charges are situated in air. The medium is air. And if the air medium is replaced by a medium of dielectric constant K, then in that case F in the medium would be equal to 1 divided by 4 pi epsilon naught K. Q1, Q2 divided by R squared. This one is in a medium, maybe water or something like that. So this is the main difference between the two forces. Once you see K here, you have to understand that the two charges are now in a medium other than air. And when the value of K increases, the magnitude of the force will decrease. So now you can make the conclusion that the force between the two charges is always greater in a medium than in air. Because in the case of air, the value of K is 1 for air. So when the value of K is less here, then the force becomes greater. On the other hand, when the value of K increases, the magnitude of the force decreases. Okay, you will see more in detail in the general course. This is just the foundation course here. We'll complete this course first, and after that we can see the general course again.